Lesson 8.6, we're going to learn to solve systems by using what's called Cramer's rule. We actually just jump right into it. We're going to use Cramer's rule to solve both 2 by 2 matrices and 3 by 3 matrices. So here it is, Cramer's rule for 2 equations with 2 variables. If a sub 1 x plus b sub 1 y equals c sub 1, and a sub 2 x plus b sub 2 y equals c sub 2. So we have a system of equations, 2 equations with 2 variables. Then the solution is written right there. X equals the determinant of this matrix over the determinant of this matrix, and then y equals the determinant of this matrix times the determinant of this matrix. Now, there's a lot of numbers and letters there, but this is actually fairly simple if we look at what we have here. Let's see if we can slide this so we can see everything a little bit bigger. So here's the things I like to notice. Here's our a sub 1, b sub 1, a sub 2, b sub 2. So notice the denominator of both solutions are the same. They are simply the determinant of the coefficient matrix. The coefficient matrix is the matrix made up of the numbers that are multiplied by each of the variables. So that's nice and simple, nice and straightforward. So the denominator is the determinant of the coefficient matrix. Then to find x, what we do, so take a look at this. We're going to kind of rewrite this whole thing here, a sub 1, a sub 2, b sub 1, b sub 2. So right now, my numerator and denominator are exactly the same. But to find x, what we do is we take out the x coefficients. So we're going to take those out. And we're going to put in the constant coefficients. So we're going to put in these. All right, so when we find x, we replace the x coefficients in the numerator. And similarly, to find y, so y normally looks like this, or not normally, but in the denominator looks like this. And so to find y, we're going to replace those y coefficients with the same constant coefficients. All right, so that is how you use Cramer's rule. You're really just finding 3 determinants because the denominators are the same. So use Cramer's rule to solve the system of equations. All right, to find x. In fact, we'll do both at the same time. The denominator is simply the coefficient matrix. So this is 3, 8, 5, 16. The numerator of x, you don't have to do this, but I'm going to do something here. I'm going to write the exact same matrix, 3, 8, 5, and 16. But remember, to find x, we replace the x coefficients with the constants. So we're going to go ahead and take out 3 and 5 and put in 5 and 10. All right, so let's do this. 5 times 16 is 80. And 8 times 10 is 80. So 80 minus 80 is in the numerator. In the denominator, we have 3 times 16 is 48 minus 40. And so we have 0 over 8, which is 0. Now, the reason I went all the way through x is because this 8 right here, that was the determinant of this, which means it also goes in the denominator for y. So we didn't have to go through that work again. The numerator, again, we'll start with the 3, 5, 816, but to find y, we replace the y values with the constants. So we're going to take out that 816 and we're going to put in 5 and 10. And so this is going to be 30 minus 25 over 8. So it is 5/8. So our answer is 0, 5/8. And that's how you find a solution to two equations with two variables. If you want, you could go to your assignment now and work through solving using the 2x2s, or solving the 2x2s using Cramer's rule. Now we have solving the 3x3s. It's actually the exact same concept. So notice that these three denominators are the same. They are simply the coefficient matrix. It's the coefficient matrix. And then the numerators, notice that to find x, we simply, for our x values, we put the constants for x values. To find y, we took the constants and put them in for our y value. And to find the third variable, z, we took out the z coefficients and put in the constant coefficients. So exact same concept, just on a bigger scale because we're working with 3x3s. All right, so these sometimes take a little bit of time, but they are definitely doable. So x, I'm going to try to write a little bit smaller here so we can fit all this in. So x is going to equal the denominator is going to be the coefficient, the determinant of the coefficient matrix. And then the numerator, it's going to be the same matrix, except we're going to replace our x's with the constants. So there's the constant matrix, goes in for x's, and the other ones stay the same. So 7, 4, 3, and then 2, -5, 4. All right, so let's go ahead and find those determinants. So we have to rewrite our first two rows. And we're going to go ahead and find what these are equal to. Go ahead and bring up a calculator if you want. And so we have 44 times 4 times 4. That's 704. 7 times -5 times 28. Oops. And then 2 times -27 times 3. Now you could have put that whole thing in your calculator all at once if you wanted to, those three things, and then added them. And now we're going to come back the other way. Remember, we subtract. And then we come back the other way. So let's see what we have here. We have 2 times 4 times 28. 224 plus 3 times negative 5 times 44. And then 4 times negative 27 times 7. All right. Let's go ahead and finish this. So this is, so we're going to take the 704. I'm going to do this green part first. 704 minus 980 minus 162. That's negative 4. I'm just going to put it above here, negative 438 minus the next part, 224 minus 660 minus 756, negative 1,192. And you combine those two together, that's subtraction, so it's adding negative. So we have the 1,192 minus 438. And so in the numerator here, we have 754. All right, let's see what we have in the denominator. So we will do our first column. These might be a little easier to multiply, not our first column, but our first diagonal. So we have negative 12 times 4 is negative 48. 35 times 2, but it's negative, so negative 70. And then 54. Again, you can do these on your calculator. And then we're going to subtract, coming back the other way. So 2 times 4 times 2, that's 16. Plus 45. And then 4 times 9 times 7. Is 252. So let's find out what these are equal to. We have negative 48 minus 70 plus 54. It's negative 64. And then we're going to subtract 16 plus 45 plus 252. Oops, I hit minus 45. It should be plus 45. Is 313. And then negative 64 minus 313. That is negative 377. And 754 divided by negative 377 is negative 2. So we get negative 2 for x. So somewhat of a chore to do that. No problem though. Now let's find y. So y is going to equal, well, the denominator was negative 377. So that's nice, we already have that done. In the numerator, we replace our y column with the answers there, or the constants. So we have 44, negative 27, and 28. That goes in the y column, and then we have the other two are going to be the same, negative 3, 9, and 2. and 2, negative 5, 4. I did not put them in a good spot. Let's move those down, that down. And then we're going to do rewrite our columns here. Sorry about that. -3, 9, 2, 44, -27, and 28. Let's see if we can do this all together on our calculator. So we're going to do -3 times -27 times 4. Going to be careful. Now let's do it. -3 times -27 times 4 plus 44 times -5 times 2 plus 2 times 9 times 28. So that's 388. We'll multiply the other direction. So that's going to be 2 times -27 times 2 plus 28 times -5 times -3 plus 4 times 9 times 44. And that is 1896. So we want to do 388 minus 1896. That gives us -1,508 over -377. Which is 4. So we get x is -2, y is 4. Now we can find z. Z, our denominator, will be -377. Our numerator will be found by using the coefficient matrix, but replacing the z values with the constants. One more time, we'll rewrite our columns. And we will find that determinant. So -3 times 4 times 28 plus 7 times -27 times 2 plus 44 times 9 times 3. That is 474. Minus, and then we're going to come back the other way. So 2 times 4 times 44 plus 3 times -27 times -3 plus 28 times 9 times 7. That is 2,359 over the -377. So we have 474 minus 2,359. Divide that by negative 377, and we get 5. Wow, so after all of that, we have our answer is negative 2, 4, and 5. In our final example here, it says if we have matrix A and matrix B, as shown, show that the determinant of A times B equals the determinant of A times the determinant of B. And since we're going to show that, we're just going to go ahead and multiply A times B, find its determinant, and then take the determinant of A and the determinant of B and multiply those together. So we will start by multiplying A times B. So we're just going to write A out and times B. And we'll do these multiplications. Go first row with first column. 3 times negative 2 is negative 6, plus negative 4 times 4 is negative 16. Next, we'll go first row with second column. 3 times negative 1 is negative 3, plus negative 4 times 8 is negative 32. And then we will do second row with first column. 5 times negative 2 is negative 10. Negative 6 times 4 is negative 24. And then second row with second column, 5 times negative 1 is negative 5, and negative 6 times 8 is negative 48. And so this matrix equals negative 22, negative 35, negative 34, and negative 53. And so now we want to do the determinant of A times B. So that's the determinant of negative 22, negative 35, negative 34, and negative 53. So that's the 22 times 53. That's 1,166 minus 35, negative 35 times negative 34. It's 1,190. We subtract those and we get negative 24. So that's the most time-consuming part of this question. Now we're going to find the determinant of A. So let's do the determinant of A. So it's the determinant of 3, negative 4, 5, negative 6. That's negative 18 minus negative 20, which is 2. And then we'll do the determinant of B. And that's negative 16 minus negative 4, which is negative 12. And so the determinant of A times the determinant of B is 2 times negative 12, which is negative 24. And so we showed that those two things are equal to each other.